Hello, guys. I hope you're well. So I would like us to go through indices and logarithms. Now, an index is basically the power which is raised to a particular number or variable. So, for example, if we have a constant like 2, which is raised to the power 3. This power right here is what we call an index. Or if we have a variable, let's say a, which is raised to the power b, this power is what we call an index. In order for us to solve questions involving indices, then it is very important for us to know the basic laws of indices. So indices, this is basically just the plural of an index. So if this power right here is our index, then this is our base. So some of the basic laws of logarithms. So if you have any number a, which is raised to the power of m, and it is multiplied by a raised to the power of n. As you can see, we have a, so the bases are the same. Then this is the same as having a raised to the power of m plus n. If you have any number a raised to the power of m, and this is divided by a raised to the power of n, this is the same as having a raised to the power of m minus n. So it's the same as subtracting the powers. Number 3, if we have a raised to the power of minus n, this is the same as having 1 over a. So basically the reciprocal of a raised to the power of positive n. If we have a raised to the power of 0, that is any number raised to the power of 0, the result will always be 1. Number 5, if we have a raised to the power of 1 over n, this is the same as the nth root of a. Number 6, if we have a raised to the power of m over n, this is the same as the nth root of a. Okay, I'm trying to find me a rubber. So this is the same as having the nth root of a raised to power m, or we can also write this as the nth root of a, all this raised to power m. Number 7, if we have a raised to, let's say, power m, and we have another number b, which is also raised to power m, these two are divided. This is the same as having a divided by b, all this raised to the power m. So basically, those are some of the common laws of logarithms that we have. So we also have the power law. If you have a raised to power m and all this is raised to power n, this is the same as having a raised to the power mn. So given any question involving indices, this should act as a guideline on how to do some of the questions involving indices. So let's look at a few examples of how to tackle questions involving indices. So So let's say you have a question like this. 2 raised to power 4, and this is multiplied by 2 raised to power 5. This is, since the bases are the same, this is the same as you having 2 raised to power 4 plus 5, and this gives you 2 raised to power 9. Let's say you have 2 raised to power 3 divided by 2 raised to power 2. Since the bases are the same and it's divided, it's the same as having 2 raised to power 3 minus 2, which gives you 2 raised to power 1. Number 3, let's say you have something like 4 raised to the power of a half. This is the same as the square root of 4, which gives 2. Number 4, let's say you have something like 5 raised to power 0. This is the same as 1. And let's say you have something like 3 raised to the power of negative 2. This is the same as 1 over 3, which is the reciprocal, raised to the power of positive 2. And this gives 1 over 9. Let's say you have something like 5 raised to power 3, all this divided by 2 raised to power 3. This can be expressed as 5 over 2, all of this raised to the power 3. Number 7, let's say you have something like 4 raised to the power 3 over 2. So this can be expressed as the square root of 4, all this raised to power 3, or you can also write it as the square root of 4 cubed. So this basically gives, the square root of 4 is 2, 2 cubed will give 8, or if you do it this other way around, 4 cubed will give 64, the square root of 64 will give you 8. So guys, that is basically how to solve some of the questions involving indices. Let's say you're given questions that contain variables. So how do you go about solving questions containing variables? So let's say you're given something like x raised to power 4, y raised to power 3, z raised to power 2, and this is multiplied with, this is multiplication, x raised to power 1, y raised to power 5, and z raised to power minus 1. So this is x. X. So how do you go about multiplying that? So you put the ones having the same bases together, like x and x. So I have x raised to power 4 and x raised to power 1. I have y raised to power 3 and y raised to power 5, z raised to power 2 and z raised to power minus 1. Using the law of logarithm that involves multiplication of two numbers with the same bases, I will add their powers. So same bases, add the powers, same bases, add the powers, same bases, add the powers. 2 minus 1 gives me z raised to power 1. So this is what we get. Example 2, let's say we have a raised to power 3, b raised to power 3, all this divided by a raised to power 2, b raised to power 4. So this and this have the same bases, they've been divided. This and this have the same bases, they've been divided. So I can have this as a3, a2, b3, b4. Since these and these are the same bases, it's the same as me having a 3 minus 2 and then b 3 minus 4. So I subtract the powers. This is a raised to power 1. This is b raised to power minus 1. And b raised to power minus 1 is the same as me writing. So this is a raised to power 1. B raised to power minus 1 is the same as having 1 over b raised to power 1. So combining all this, I have a over b as my final answer. Finally, let's look at this last example here. So if you're given something like 27 raised to the power of 2, 3, so how do you go about this? So as from the laws of logarithms, we've seen that we can be able to write this in two ways. So this is the same as what is down here is what makes the root. So this is the same as the cube root of 27 raised to power 2. Or we can also express it as, so let's first of all do it this way. This is the same as the cube root of 27 squared. So what is 27 squared? So that's 729. So the cube root of 729, that gives 9. Or we can also write that as 27 2 raised to power 3. We can have it as the cube root of 27, and then all this raised to the power of 2. So what is the cube root of 27? The cube root of 27 is 3, and 3 raised to power 2 will give 9. So that's it. If you're given any questions that involve indices, then those are the basic laws that you need in order for you to solve the questions. Now, let's look at logarithms. So let's look at logs. So when a number y is expressed as an index as a raised to power x, x is called the logarithm and a is called the base. X is called the logarithm and a is called the base. So if we have an index like this, then we can be able to rewrite this into log form as log to base a of y is equal to x. So x is called the log to base a of y. X, which was initially the index, is called log to base a of y. So this is basically the principles that governs also conversion from logs to indices and indices to logs. Let's take up an example. Let's say we have something like log to base 2 of 3 is equal to x. This is the same as in index form. Writing this as an index is the same as taking 2 raised to power x is equal to 3. Basically, that's how you write from a log to an index and vice versa. So this is very essential if you want to convert from logs to indices or from indices to logs. Now, one thing that we need to know is that we can easily evaluate logs from the calculator. However, from the calculator, the only logs that we can be able to evaluate are log to base 10, which is also expressed as log or also as LG. And this is called common log. We also have log to base E. E is a mathematical constant in the calculator. So this in the calculator is expressed as ln, and this is called natural log. So these are the only 2 logs that you can be able to evaluate from our calculators. However, these are not the only existing logs, because you can be given questions involving log to base 2, to base 3, to base 4. So it's very important for us to know the laws of logarithms so that you can be able to solve these questions. So let's look at laws of logarithms. So the first law we're going to look at is, if you have log to base b of a plus log to base b of c, where A, B, C are just any, stands for any constant. This is the same as having log to base B of AC, or A times C. If we have log to base B of A minus log to base B of C, this is the same as log to base B of A over C. And if we have log to base B of A raised to power n, this is the same as having n log to base B of A. Okay, so let me write here. Let me hope this space is going to be enough so that you can be able to see all of them at once. So if we have log to base A of A, this is the same as 1. And if we have log to base A of, let's say, B, this is the same as having 1 over the log. Now it becomes base of B. So, and if we have log to base B of 1, this is the same as 0. So log to any base of 1 will give you 0. So these are the basic laws of logarithms that will help us to solve any question that involves logarithms. And the last thing is, let's say you would like to change to log to base 10. So how do you go about that? So let's say you have log to base B of A, and you'd like to change this to log to base 10. So how do you go about that? So changing this to log to base 10, it will be log to base 10 of A all over log to base 10 of B. So up to that point, I've already given you all the basics that we require in order for us to solve questions on indices and also questions on logarithms. So let us look at a few examples of questions on logs, and then you can be able to now tackle some on your own. So let's say you have log 8 plus log 12.5. So this is when it's given as log and the base is not indicated, it's obviously log to base 10, meaning we can be able to evaluate this directly from the calculator by inputting log 8 plus log 12.5 in the calculator. However, let's say you're told to evaluate it without using a calculator, because that's also still possible. So how do we go about it? Now, using the law of addition, we can be able to rewrite this as log 8 multiplied by 12.5, which is the same as log 8 times 12.5 is the same as 100. Now remember, if the base is not indicated, it is obviously log to base 10. So this is the same as log to base 10 of 100. Now this can be written as log to base 10 of 10 squared, because 100 is basically 10 squared, which using the power law can be written as 2 log to base 10 of 10. And we already know that log to base B of B is 1. So log to base 10 of 10 is 1. So this gives us 2 as our final answer. Let's take up another example. So let's say you're told to evaluate log 40 minus log 4. So we can be able to write this as, since there's subtraction between them, we can write this as 40 divided by 4 into 1 log. So this is the same as log 40 divided by 4 will give 10. Since the base is not indicated, it is obviously log to base 10. So this is log to base 10 of 10, which gives 1. Let's look at example number 3. So let's say you're told to evaluate log 27, all this divided by log 3. So this is the same as, we can write this as a log 27 is the same as 3 raised to power 3. All this divided by log 3. Now, using the law of logarithm, I can be able to rewrite this power in front so that I have 3 log of 3, all this divided by log 3. This and this are similar, so they can cancel out so that I remain with 3 as my answer. Let's take up a final example. So this is example number 3. Let's take up a final example, example number 4. Let's say you are told to evaluate log 120 plus a third log 27 minus 2 log 6. So how do we go about doing this? This is addition, this is subtraction. So this is the same as putting all this under one log. Addition, first of all, let me have this as log of 120 plus. Let me bring this power to this other side so that it is log of 27 raised to power third, using the power law that I already gave, and bringing this to this other side, it will be log of 6 raised to power 2. So I'll have this as log of 120 plus log of 27 raised to the power a third is the same as, so first of all, 27 is the same as 3 raised to power 3. And then this is further raised to power third. So using laws of indices, I can be able to multiply the powers. And then I have this as log of 6 squared. 6 squared is 36. So this is log 36. Okay, guys. So I have log 120 minus 3 times a third will give 1. So this will be log 3 minus, sorry, this is addition, log 36. So putting all this under one log, I'll have log of 120 times 3, all this divided by 36. So this gives me log of 10. And as I've said before, if the base is not indicated, it is obviously log to base 10 or 10, which gives 1. So that's the end of this session. The next session, I will do more examples from NEC past papers and then share them with you guys.